All right, I'm going to do WebAssign problem 10 of charge and Coulomb. Charge and Coulomb, I think is what it's called. Problem number 10, which has the spring. So we have a spring with a charge. Now it's a charge. I'm going to call this Q1. Now for me, that happens to be 8 microcoulombs, but everybody has a different value for that. And then we have, I'm going to exaggerate this, but down here we have a -4 microcoulomb charge and a -4 microcoulomb charge. And because of the attractive force of Q1 to this, I'll call this Q2, because of that attractive force, it pulls this down another 5 centimeters. So here, the spring is stretched 5 centimeters, and the spring force, Fs, is equal to Kx upward. Rings a bell, doesn't it? All right, so that's 5 centimeters, or 0.05 meters. That's the same for everybody. Now, what we need to do is figure out the spring constant, this K. And it's going to be done with the forces. But the difficulty of this problem arises, I think, from the geometry here. So let me just draw this out. Let me draw a vertical line here. The problem gives us 0.02 meters here, 2 centimeters, and 0.02 meters here, 2 centimeters. Now, because of symmetry, I'm going to just analyze one side here, and then we'll double the force between this and this, trying to pull this down, is really doubled because of the other side. So let's ignore the other side and just consider one side. I'm also going to call this theta. I think that'll help, because basically we have a right triangle here. Now the distance from here to here is b, and that's given in the problem, and that's different for everybody. I'm going to call this d for the distance, because Coulomb's law, K, Q1, Q2 over d squared is equal to Kx for the spring. Now don't confuse these K's. This is spring constant. This is Coulomb constant. All right, so let's go ahead and I'm going to put a number in for that just to make sure. So I'm going to say 9. Let me just write E9. E means times 10 to the. It's kind of WebAssign symbology anyway, right? So 9e to the 9th, Q1, Q2 over, I'm going to go ahead and bring the x down here because we're really trying to solve for k, and then d. What's d? Well, d is the square root of the sum of the squares. So, and it's d squared. So really what it is, I'm going to go ahead and be explicit about this so we don't get confused. D is square root of b squared plus this distance squared, 0.02 squared, right? So there's that. And that whole thing is equal to k, which is what we're trying to find. Darn it. We're trying to find k. All right, so we're well on our way. But here, let me zoom in one more here. I don't know if that'll help or not. Boop, there we go. Look at that. Okay, so this is the spring constant we're looking for, but I've missed something here already. You remember I said I'm analyzing one side here, this force, and so we got to double it for the other side. Actually, there's 2 things we have to do, and this is what makes it a little confusing. Let me write this: not complete, not complete. All right, let me be more careful now. It's the vertical component of this electrical force that acts in this direction. This is the direction of the electrical force. We need the vertical component of that. And we got to double it for the other side. So what we really need is this. K is equal to, all right, we got to double this, 2 times 9e9. Q1, Q2 over x. By the way, this is equal to x. It's the 5 centimeters, 0.05 meters. But, and this is d, and I kind of messed up on that too, because this is supposed to be d squared, right? So we've got to really be careful here. So it's twice for both sides. 9 times 10 to the 9th, q1, q2, x. Now I can write, because this is squared, I can write b squared plus 0.02 squared. Okay, the squared takes care of the square root. But because it's the vertical component, it's cosine of the angle. Cosine of theta. Cosine of theta. And that's equal to, let me go ahead and write it now a little simpler. That's going to be 18 e to the 9th, q1, q2, over 0.05, because that's how far it got stretched. That's the x. Everybody has their own b. B squared plus 0.02 squared. Cosine of theta. Cosine of this angle, adjacent, so that's b over hypotenuse. And the hypotenuse is square root of b squared plus 0.02 squared. Oh my gosh. All right, and so that's equal to k. Now, let us go ahead and we'll deal with this a little better. So this whole thing is equal to 18 E9 Q1 Q2 over 0.05. Now, but put a b up here. There's the b. Bring that down. And 0.05, b squared plus 0.02 squared times square root of b squared plus 0.02 squared. Well, this is to the 2/2 power. This is the 1/2 power. So really that's b squared plus 0.02 squared to the 3/2 power, which is the 1.5 power. Now I think I have everything in order. I sure hope so. Now I'm going to go ahead and plug in the values that I have in the problem. Here, I'll bring this up over here. Okay, so I got 18 e to the 9th. Now Q1 is 8 times 10 to the negative 6th. That's microcoulombs. Q2, 4 times 10 to the minus 6. B, for me, B is equal to 0.042 meters, 4.2 centimeters, and you have a different value. So 0.042, and then divide this all by 0.05, and we also have b squared, so 0.042 squared plus 0.02 squared to the 1.5 power, and that should be equal to k. All right, so now the rest of it's probably just a waste of time. 18E9 times 8E negative 6 times 4E negative 6 times 0.042. I'm just not even trusting myself to do this right in the calculator. This is 0.0242 divided by 0.05. I know I should do this all one step, and I'm just showing you here. I don't know what I'm showing you, that I can't use the calculator very effectively. Okay. Quantity 0.042 x squared plus 0.02 x squared. Quantity raised to the power 1.5. Enter. This number here in the denominator for me is 5.03 e negative 6, which is equal to, see, divide by 0.0242, enter, and then take x to the minus 1, enter, and that's equal to 4,800 newtons per meter. And fortunately, that is the answer given for my particular values of B and Q1. So I hope that helps, and may you have great success with this wonderful little problem.